Hey guys, what's happening? Welcome back to e-learning. I'm sure this is going to be great for you. Um, we're going to keep going over molarity. So I'm going to go over these Unit 10 notes. This is Unit 10 notes 2. I don't have a scanner, so you're going to start seeing pictures of lined paper. All right. So if we go through this, you guys remember molarity. Molarity is just moles over liters. We did this quite a bit. If you were given a mass of solute, which is what's being dissolved, you have to convert that to moles because molarity is moles over liters. Volume must be in liters. I put some examples up. They're example sets. Example set number 1. You can go look on Canvas. I've also made an answer key so you can go through those problems and see if you have any questions. Uh, One of the things that we have to make sure we understand now is this idea of dilution, which you guys all get. It's if you dissolve a certain amount of solute, then you start adding more solvent. So in our case, we dissolve something in water and then we add more water. Think about it like Kool-Aid. All right. You can see I messed up a little bit down here. I'm going to kind of get this all set up. Here, we have 5 dots here, and each dot equals zero point 0.1 moles. This amount of water, that's a half a liter. So we get 0.5 moles divided by zero point 0.5 liters, and we get a concentration of 1 molar. That wasn't too bad. All right. But now here, I'm going to add 250 milliliters of water. So we're going to add the amount of water. We're diluting it, sort of like you put a pack of Kool-Aid in here and then you add more water and you dilute it. You could still see the red dots. There's still 5 of them. Each dot's 0.1 mole, which means we still have 0.5 molar, or excuse me, zero point 0.5 moles. That hasn't changed. However, what has changed is we've added 250 milliliters. So now our volume is 0.75 liters. We've diluted it down to a 0.67 molar solution. So we've taken the concentration and we've lowered it. And one way that we can look at this is here. This is our equation. M1V1 equals M2V2. All right, because molarity times volume gives us moles, and the number of moles doesn't change, which means here in this scenario and here in this scenario, the number of moles has to be the same. There's no change there. So this equation holds true. What will be very important is for this V2, if you add more water, you need to take the volumes of water and add them together. For instance, we did this, or I did this down here. If I move on down, here we had 1 molar, we had 0.5 liters. What is our second molarity? Well, our second volume is 0.75 liters because I added that 250 milliliters of water. Do a little bit of algebra, we get 0.67 molar. See example set 2, not a big deal. If we jump down here, we can dissolve more than just solids in water. All right, we can dissolve gases in water. And we know this because fish breathe. Fish filter out dissolved oxygen from water, and that's how they breathe. That's what their gills do. And so here, there's no values here, uh, but this is the molarity of a gas. You know, how many moles, what's its concentration. And as the temperature increases, you can see that concentration of gases is decreasing. All right. So as temperature increases, gases become less soluble. Okay. So that's just for any gas. Like we're not working with values here. This is our concentration. This is the pressure of said gas. So as pressure of a gas goes up, more of the gas dissolves. And so you can see that line here. So we increase temperature, concentration goes down. Increase pressure, concentration goes up. How is this relevant? Go down here. We've talked a little bit about this, but it has to do with gases that are dissolved in the ocean. All right. So if we increase the temperature of the ocean, which is happening, water temperatures are going up, that means there's less dissolved oxygen. And fish need that in order to breathe. And so this is a problem that's happening because for every little bit that the temperature increases, we have less and less oxygen available for fish. The other problem that's occurring is there's more carbon dioxide in the air. You can see we have more CO2 in the air, which means there's a higher pressure of CO2. If we have a higher pressure of CO2, that means more carbon dioxide is dissolved in the ocean. And when carbon dioxide gets dissolved in the ocean, CO2 reacts with water. Here's our reaction, and we get carbonic acid. So the oceans are becoming more acidic. This is problematic for fish and coral reefs and things like that. So this is why I'm talking about it, and something just to keep in the back of your mind.